All right, hello everybody. My name is Andrew. I'm with ACI over here in Spokane. So today I'm going to talk about GREE opportunities for solar VRF and hot water heat pump systems. To start off, I'm going to quickly go over who GREE is, since a lot of you probably haven't heard of GREE before. So GREE is the largest HVAC manufacturer in the world. They're based over in China. They are dedicated to creating cutting-edge technology. They produce over 30% of the world's HVAC products. Just to give you a feel for how large they are, the Forbes 2000 list, they were ranked as number 246. That is the largest HVAC company that was on the list, and that list of 2000 was all companies globally. They have 12 factories, and every piece of the equipment comes from one of these 12 factories. So they build everything from the electric motors to the compressors to the plastic injection molded covers for the wall mounted fan coils, etc. Every part of the unit is made by GREE. So I'm going to jump right into the solar VRF. So the 3, 4, and 5 ton mini VRF units are able to be powered directly by solar panels. And that is the same for the 6, 8, and 10 ton heat pump VRF units. So what does this mean? It means we can plug solar panels directly into the units with no need for a separate inverter. We can also plug AC power directly into the unit at the same time. This allows us to provide adequate power to the unit no matter what the solar conditions are. So for example, we have a day that is cloudy. We don't have enough panels to generate enough power to run the unit. The inverter inside the unit will automatically draw enough power from the grid connection to power the unit. On the other side of things, if we have a sunny day and we have enough solar panels that will power more than just the unit can feed the power back into the building, and it can also sell power back to the utility grid if you set it up appropriately. So the inverter built into the unit eliminates the power inverter that you would usually buy separately. So here's the wiring diagram that shows the AC power connects to the L1 and L2 terminals, and the DC power connects to the QF terminals right there on the terminal board. And I've got a picture coming up here that shows what it looks like in real life. So here's a picture of an installation down in Florida. Here's another installation of a job shack trailer. This one has only solar panel operating the entire building, and all the solar power is going through the VRF unit. So here's a picture of an installation that we have in the Seattle market. You can see on the center there, we have the D1 and D2 terminals for solar. So this unit doesn't have solar connected to it currently. The units don't have to have the solar panels connected in order for them to run. So we can use these as straight AC power if we need to, or we can use them as straight solar, whichever is convenient for us. So you can see this one's connected to grid power at the L1 and L2 terminals, but it is not connected to the solar on the D1 and D2, but it is as simple as that to connect it to solar. All you need is 6 to 12 of these 325 watt panels shown on the left. That's a standard size panel. You do not need any extra inverters in order to connect this in. Since I'm not an electrical engineer, I don't know if we need extra disconnects or such to meet the electrical code. That would be something for an electrical engineer to answer. For controls, so we have the full range of VRF controls, programmable thermostats, non-programmable. We have key card thermostats and central controllers. So the central controller here, the solar specific model, will tell you how much power you are pulling from solar, how much you're feeding back to the grid, how much energy you're saving using the solar panels, along with all of the typical features of a VRF central controller. Here's a photo of one of the indoor units at that installation that we have in Seattle. It replaced an old Lennox furnace that was there in the building, and it was able to mate up with the existing duct connections and fit right there in the existing slot. The GREE's GIEMS system is the app-based system that will take a look at the solar power that's coming in and monitor everything. Intelligent monitoring, they call it. Soon, in the next couple of months, GREE will launch their battery power system that can be attached to the VRF system, and the IEMS management system will be able to switch to battery power, grid power, solar power, and it can also direct the solar energy to different portions of the building. So if you say have a building with a parking garage and you want the solar to go mainly to charging up electric cars, the intelligent energy management system can direct that. So as I said, it's also can be used just as a standard VRF system. We do also have non-solar VRF systems, but we can connect up to 80 indoor units. And here's a picture of all the indoor units that we have, everything that you would typically expect from a full range of VRF. Quickly just show the size ranges of some of the units. We do also have a fresh air handler, so that unit can bring in 100% outside air and condition it. And we also do have an AHU kit for connecting to a third-party coil. That is pretty useful for DOAS systems. So I've talked about the solar. The solar has implications for the energy code for generating renewable energy on site. We feel that that's the simplest way to meet that part of the code, basically by just ordering the solar VRF system because it's solar ready. Then all you have to do is add some panels to it and connect them right in, and you saw how simple that was. So now I'm going to move to the air to water heat pump. Since heat pumps are getting such a strong emphasis in the code this year, we feel that it would be important to take a look at water heat pumps. So this is a split system. The outdoor unit is a 54 MVH nominal capacity, and it connects to an indoor unit that has a water to refrigerant heat exchanger. And then you can connect it to a third-party water tank if needed. Here's a cutaway view of the indoor unit. So you can see the plate heat exchanger in there and the expansion tank and also the electric auxiliary heat. So these units will operate down to -4 degrees ambient temperature. Below that, the electric auxiliary heat will kick in. Cutaway view of the outdoor unit. It's pretty standard mini split outdoor unit. It does have an inverter compressor and electronic expansion valves. So this unit can be used for space heating. So we can provide water temperatures that are appropriate for space heating for either underfloor radiant, fan coils, or radiators. We can also generate cold water down to 44.6 degrees if you need space cooling, and that is with an outdoor temperature of 50 to 118 degrees. So we can also do radiant slab cooling, overhead radiant cooling, fan coils, etc. With cooling. And we can also do domestic hot water. So you will likely want to use a auxiliary heat for your hot water tank because we can't do simultaneous heating and cooling. So for example, if you have a summertime condition where the air conditioner is running, but someone wants to run the hot water, we can set hot water priority in the controller. So it will switch from generating cold water to generating hot water to maintain the hot water heat for the domestic hot water system. And then it'll switch back to cooling mode for the fan coil. Here's a simple diagram of a system that is just doing space conditioning, heating and cooling for space. Here's a simple diagram of a system that is doing domestic hot water. And here's a simple diagram of a system that would be doing both. Now, since these are only 54 MVH nominal, they're probably ideal for maybe smaller office buildings or residential use, something like that. We do have an 8-ton system that'll be coming out sometime next year. That'll be available soon. The 8-ton system also will have a 55-gallon water tank available with it. We do have all the UL, ETL certifications that are required, so all the solar product is UL listed. The Versati heat pump hot water system is UL listed as well as being AHRI certified performance. So I see a question, do you have to use GREE radiant heaters? So we can connect, if you're referring to the Versati hot water heat pump product, all we provide is the outdoor unit and the indoor unit, which is the refrigerant to water heat exchanger box. So you can connect that to any fan coil or radiant heat system that you want, or hot water tank, anything that you want on the hydronic side. We just have the refrigerant side. Air to water heat pump potable rated. So you're going to want to use, I suspect this is what you're asking. So you're going to want to use a hot water tank with a heat exchanger in it. So one of those hot water tank styles that is made for heating your potable water with hot water or steam. So the water coming out of the GREE unit, you're going to want to run through a heat exchanger for potable water. Can you twin multiple 8-10 ton units together? I think this is asking about the solar VRF. Yes, that is correct. The 6, 8, and 10 ton modular models can be twinned together up to 30 tons on a system. Heating performance at 24 degrees outside air temperature and producing 130 degree water. I have a request of the factory to pull the D-rate chart for the hot water unit. I do just have a basic cut sheet that says that it operates down to -4, and I will take note of that and shoot an answer out to you for that. I appreciate your time, and please contact us if you do end up with any more questions or potential applications for these units, or if you want to discuss them further, give us a call.